In this next lesson, we're going to look at how the definite integral is related to the antiderivative. Without a lot of explanation, we're told that taking the derivative of an integral will give us the function back. Now notice the variables are a little bit different here. They're putting t's in here. They're taking an integral where x is the upper limit of integration, and then it takes us back to f of x. But really, whatever function we have in here, when we take the integral and take the derivative, it will just give us the same thing back. So what this would tell us is if we have any function, they use a capital F for this, and if we think about the derivative of that function with capital F, its derivative would be f of x. That means if I take the antiderivative of f of x, okay, and we're going to be using the integral here, then that antiderivative is going to be our original function f of x, but it could be plus any constant. We don't know what that constant is. If we plug it in using the definition that, or our theorem that going from a to a is always going to give us 0. So whatever number we plug in here, and we choose that by whatever x we want to start with, maybe going from 3 to 3 or something, that will always give us 0. And the antiderivative then would be f of a plus c with the capital F, and solving that for our constant, notice that our constant is that lower limit minus that lower limit. That gives us this definition here. Anytime we want to work out an integral, what we're going to do is, notice that that derivative part's gone now. What we're going to do is we're going to take an antiderivative, but notice that we're ignoring the plus c part. And we're ignoring that because even if I did leave that in here, if let's say I said plus c and plus c, that would cancel out because this would be minus that plus c. And so when I take that antiderivative, we would plug in the upper limit to the first one, and we would plug in the lower limit to the second one. Okay, let's look at an example. Here I have the sine of x dx. I want to find it from 0 to pi. So the first thing that I want to do is take the antiderivative of that, which would be, if it's antiderivative of sine, would be negative cosine of x. And normally we would say plus c, but when we're working out the integrals, we don't need to do that. Okay, so cosine of pi, okay, that's our upper limit of integration, minus cosine of our lower limit, 0. Okay, so we used our antiderivative both times. Cosine of pi would be negative 1, so I have a negative negative 1. Negative negative makes that plus, and then the cosine of 0 is 1, and so I get 2. So working out this integral, that area would give me 2.